Okay, Unit 5, Day 4. They want us to label all 16 angles. I would not do these in the order they're shown. I would start here with pi, because that's what we know, and 2 pi. Well, half of pi is pi over 2, and half of pi over 2 is pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which reduces to 3 pi over 2, 7 pi over 4, and 8 pi over 4, and 8 over 4 is 2. Next, I would do the 30 degrees. We need to know that 30 degrees is pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. You can see the ones that could be reduced to the ones that are thirds. That's the order I would do them. It would make more sense to me than trying to go one by one by one. In example 1, they want you to find 4 coordinates that are easy. So if you go back in the unit circle, this is the point 1, 0. This is the point -1, 0. This is the point 0, 1. And this is the point 0, -1. Those 4 should be easy because they're 1 unit away from the origin. Next, we're going to define a reference angle. A reference angle is an acute angle, so between 0 and 90, and it's with respect to the x-axis. So here we have the rotation angle. Clearly it's bigger than 90, but then here is the angle with respect to the x-axis. This is acute. Here's the rotation angle. It's bigger than 180, but the reference angle is the acute angle between 0 and 90. And it's a positive angle, 0 to 90. Here is the rotation angle. It's between 300 and 360, or 270 and 360. But here again is the reference angle with respect to the x-axis. We do not talk about with respect to the y-axis. Since they want us to talk about a special right triangle in quadrant 1, we can see that the angle is not 45, it's bigger than 45, so the special one must be 60. And the 60-degree angle triangle that I know, 30, 60, 90, that I remember, because I'm not very good at fractions, is this is 1, and it's half of an equilateral triangle. So that's another 1, so this would be 2, this would be 2. Equilateral, this is 60, this is 60, this is 60. And if this is 60, half of 60 is 30, and here is our 30, 60, 90 right triangle. If the hypotenuse is 2 and the short leg is 1, using the Pythagorean theorem, the long leg is √3. But since they want the hypotenuse to be 1, to make 2 1, I divide by 2, divide by 2, divide by 2, and I get these other 2 sides of this 30, 60, 90 triangle where the hypotenuse is 1. You can see the 3 other triangles that are the same, but because we're going to the left, this is -1/2. Going down, this is -√3/2. Going down, this is -√3/2, but this is still going to the right, so it's +1/2. And so I get these points for the other 3 quadrants, but once you get the first quadrant, it should be pretty easy. Same thing here. This would be 45 degrees. This is smaller, so this must be 30. So then opposite the 30 is the half. The long leg is root 3 over 2. The hypotenuse is 1. And so we can again label this as to the right root 3 over 2 and up a half. This one's going to be to the left root 3 over 2, but still up a half. This one's going to be to the left negative root 3 over 2 and down negative a half. And this one is going to be the right, so it's positive root 3 over 2, but it's down 1 half. So again, once you know 1 point, you really know 4. So here we do have it right smack dab in the middle. So this is a 45, 45, 90 right triangle. The one I remember, because it's easy for me, is 1, 1, because if it's 45, 45, if the angles are equal, the sides opposite are equal. And if I do the Pythagorean theorem, this is going to be root 2. But again, we want the hypotenuse to be 1, so I divide by root 2, divide by root 2, divide by root 2. And if I rationalize the denominator, in other words, get rid of the radical in the denominator, I get root 2 over root 4, but root 4 is 2. That's why I chose it, to make the bottom perfect. So if this is that side, this should be the same. So again, to the right, root 2 over 2, up, root 2 over 2. This time we're going to go left, root 2 over 2. Still up, root 2 over 2. This one we're going to go down, root 2 over 2, and, left, root 2 over 2, and down, negative root 2 over 2. They're both negative. And here, to the right, so it's positive root 2 over 2, but down, negative root 2 over 2 for the point in the fourth quadrant. So again, we're going to talk about a reference angle. Well, here's the rotation angle of 345. And so we should know that all the way around is 360. So this is going to be short of this x-axis by 15 degrees. Again, the reference angle has to be between 0 and 90. Now in the radian world, we can see that halfway around is pi. And if we think about common denominator, isn't pi the same thing as 6 pi over 6? Well, if the rotation angle is 7 pi over 6, one more pi over 6, there is the reference angle. If we're talking about radians, and this is pi, which is 3.14-ish, and this is 2.9, it's pretty close to 3.14-ish. So this part that's left is pi minus 2.9. Now remember, pi is not 3.14. It's about 3.14. Pi is exactly pi. And I just leave it as pi minus the 2.9. You try the other three using the same thoughts. The answers are here for you to see them.